But big title, right? Orbital Sidekick 2024, design at OSK. What is OSK? Well, let me start with introducing you to who I work with. I have the pleasure of working with this small team of some of the most talented scientists and engineers that I have ever worked with in my life. And I, as a designer of one, I have the pleasure to support these people every day. And the one tool that I have learned as a designer when working with them is the power of listening. It's the power of having empathy and trying to understand how I can use design as a service to serve and help these scientists and engineers do their job and get their job done. These could be remote sensing experts, GIS experts, business and development people, software developers. Together as a whole, OSK is this core group right here. And there's other people who are not in the picture. We operate in San Francisco, and we also operate abroad across the nation. And these are the people I have the pleasure of working with. But beyond the people, there's more than just the people that's the story. And at OSK, our story is that we have a focus on sustainable operations. Our mission is to enable customers to know now and act fast. Our satellites and technology can be used to monitor all sorts of things like pipelines, mines, and farms. We can track changes over time, spot potential problems, and help businesses and governments make smarter decisions. Because at the end of the day, it's the story. It's about using our data to create a more sustainable and insightful future. And at our core, I said we're a hyperspectral imaging company, but what is hyperspectral? I brought this book along today, this giant book, Hyperspectral Imaging Remote Sensing. One of the gentlemen who co-authored this book is on our technical advisory board. You're welcome to check it out if you want. Yeah, but as a designer, when I started as a designer of one, which I still am, I had to think to myself, what is hyperspectral? What's all this technical jargon and stuff? And the more I worked with those people, the more I learned that there's this beautiful scientific world out there beyond just what we see with our own eyes. The red, green, and blue is what we see in terms of wavelengths. But with hyperspectral, you can see way more. And it's all about the color. It's all about the colors. So we use our satellite constellation to use hyperspectral imagery, and we can image and chemically fingerprint the Earth at about an 8-meter GSD scale. And you can see to the normal eye, that just is an image. But if you apply hyperspectral to it, you can see way more. Maybe that's an important methane detection site that could end up being a really big disaster. But with the power of hyperspectral, you can know now and act fast. And my domain is a little bit in the pipeline, but it's predominantly over in the software side. It's in the product area. And we built this really cool tool called Sigma, Spectral Intelligence Global Monitoring Application. So the story continues. Where did this all start? With satellites, there were things that came before satellites. OSK started in our co-founder's garage in San Francisco. And eventually we got to an inflection point where around 2019, a sensor was launched up to the International Space Station. And that was a successful proof of concept. That was to prove to people, look what we can do. Then around 2021, research and development started. What would it be like if we put a sensor in a satellite and not just on the International Space Station? Full integration of systems. Then comes your path to commercialization, Q2 of 2023. And I onboarded around 2022 as the first designer. And that's when we launched Ghost 1 and 2, and then Ghost 3. And I have to say, that's where things got really serious, because no longer were we experimenting with data. We were getting data, a lot of data, like terabytes of data all the time, every single day. So it's been an exciting journey, and we're really proud of what we've built, and we plan to launch another one soon. And a little bit about what Ghost is. Well, here's some tech specs of Ghost for those who like to learn about technology specs. But I'd like to point out two important things about our imagery from these specs. And it's that our satellites they can give you super stark images for hyperspectral. Like I said, about 8 meters GSD. And we capture far more information than your regular satellites on the market, with over 472 different spectral bands. And this gives us an incredible amount of data to work with. And here's what GHOST looks like deconstructed. I'd say the most important part of GHOST is this center part right here, the consensus. All of this comes together across the nation with different companies we contract out to, Corning, Astro Digital, and we send it to Vandenberg Space Force Base, and then we launch it on a SpaceX Falcon 9 rocket. And to show that, here's what it looks like in space. This was when we launched GHOST 1 and 2 on Transporter 7. And you can see that my team did GHOST 1 and GHOST 2. And when it detached, and you heard the SpaceX people say, separation confirmed, GHOST 1 and 2, everyone was ecstatic and cheered. And that's when I knew things were about to get really big. When you launch the satellite, something else happens. There comes the process of satellite commissioning. And it's a thing called first light. It's a really big thing in geospatial satellites. It proves that what we have is real. It proves that what we have has meaning and is a part of our story. And if you look at our first light, you can see we have this rich and diverse spectral signature going on. This was imaged over Arkansas. And you can see the filter being applied to that. And what you can infer from that, there's so much rich detail for a scientist or an engineer to infer. Now, how does that image get to the ground? So the first light gets processed, but what does that mean? It's processed. It's a pipeline. It's a data pipeline. It's kind of like a workflow in product design. Our current operational workflow pipeline starts with satellite tasking, then it does onboard processing on the computer, on the satellite, and then while on the onboard processing, you can conduct all sorts of things like analyzing the spectral signatures, doing algorithm processing, and then being downlinked eventually to the ground stations, commercial ground stations, to a server. And then there's even a tertiary pipeline as well for data processing with Amazon Web Services. So with all those images going around the world, we offer two primary imagery data products that cater to a diverse customer need. And the first option provides what we call unrectified and uncalibrated imagery that's suitable for clients with advanced processing capabilities. Those are usually first world governments or large federal organizations who have the resources and abilities to do processing on their own servers elsewhere. If you were a more commercial person, say you were in the energy sector, you may not want that. You might just want us to do geo-referenced and calibrated, because with that option, customers are able to get all of the rich detail overlaid over them. And on the right-hand panel, you'll also see some of our UI for our platform for Sigma. So where do all those fancy images go? Like I said, Sigma. And we built this wonderful cool tool called Sigma, the acronym. In space, you have a lot of acronyms. We call it Spectral Intelligence Global Monitoring Application. And what it really does is it makes it easy for you to explore our data. It also makes it easy for my coworkers to explore the data. And you can search, order, and even request new pictures right from the platform. So it's kind of like having your own space personal assistant for all of your data. We also have two other products we're building, Sigma Monitor and Sigma Carbon. Sigma Monitor is predominantly targeted towards environmental, defense, health, ag, infrastructure. Anyone who wants to have what they call AOI monitoring, area of interest, you could draw a rectangle around a map and constantly image that area over time repeatedly. And of course, carbon is also in more of our environmental and forestry area. We want to really empower the transition to net zero. We're all about sustainability. Then there's the technology. How does all this stuff come together? Well, we leverage a lot of analytics in our engines. We use a tremendous amount of artificial intelligence, machine learning, performance modeling, synthetic data generation, and automated analytics to really crunch the numbers and then send it to our platform and let our GIS experts at OSK or our remote sensing scientists do their job. To further show that, here's some different algorithms and types of things you can develop with these applications. Things like methane leak detection can be a refined algorithm. Mineral exploration, let's say you want to look for lepidolite. What can you do with lepidolite? Lepidolite can be used for lithium. Maybe you can use lithium batteries for that sustainable transition environmentally in our ecosystem. You have oil spill detection. Let's say you want to know now and act fast before an oil spill gets really big. You could see that before it becomes big. Right-of-way intrusions and vegetation speciation. Those are very important things for different industries. You could say right-of-way could be if a vehicle moves along someplace it shouldn't be. Or vegetation speciation. Let's learn about the different types of trees in a rainforest. You could do all of that with hyperspectral. And to show a little bit of that application, in 2024, on May 30th, we were able to find a very large methane plume going over Oman. We detected it within 24 hours of data acquisition as well, which is pretty impressive. So that's a lot of scientific information, right? That's a ton of scientific information. And I, as a designer, have had to learn all about that stuff. And I've had to learn to speak the language and really listen and use my listening skills to work with those really talented scientists and engineers in OSK. And as a designer, I feel like I start in the uncertainty. It's a lot of unraveling. It's a lot of asking my coworkers what's possible with what we can envision, what we can future cast. The process is full of messiness. And I think sometimes you will evidently drink from what I call the scientific data fire hose. There we go. So the most rewarding part, though, is when I get to see my work get to that unique cultivation moment where we release our tool or our feature or our design deliverable out into the public or into the hands of a customer or into the hands of one of my coworkers, and they get to play around with it. We get to refine it. We get to add to it. We get to learn about how someone's using it. But how do you get there? At OSK, we have a few principles of design, and principles are important to OSK. We worked with our founders at Orbital Sidekick to map out how we wanted our work to be portrayed to tell our story. When designing, we wanted to always ask ourselves if what we're doing is right and if our deliverables tell that story poetically. It's important to also have our craft and have a lasting impression that fits our mission points. We want to focus on things like utility, use our tools to get to the useful, have agility, move fast and adapt quickly, and partnership. Because why? We're always in service to you, the people, to the ends of the earth with our data. Now, lastly, personality anchors are also important too. Together, these anchors can help our experiences stick with whoever will be interacting with our designs. And at OSK, we want our work to possess the personalities of help, optimism, change, and story. What are some of those methods? Well, this is a great example. Back in, I'd say, the fall of 2022, I had the pleasure of visiting the Permian Basin with a customer. And this was a great example of us working with a customer to understand how we could add Sigma to their process and their workflow. And this gentleman, who's a senior operator, took us out into the field and we ran analysis with him. We watched him probe the ground with a stick and take the stick out of the ground and smell the stick and look for possible methane leaks in the soil. There's all sorts of sensory inputs going on. We were able to observe all the tools that they use. The transportation, I got to ride in this very, very busy. We also learned about all the software and hardware they have at their facility. And another funny story to this, I remember we were out in the field, there's grass like up to here. And I remember walking for like 30 minutes with this person and my coworker, Cooper. And then he turns around and says, oh, by the way, watch for snakes. Oh, it's getting serious. The designer's out in the element. So those principles also echo further. We love to be narrative with our approach as well. Fieldwork photos are great for documentation. They really help us identify what's going on. But the most rewarding picture was when we saw this. When we saw this gentleman use our overlays out in the field and look for this detection and say, where is it? And he was able to find it. We also do a lot of ideation. We experiment and we critique. I'm sure we all use Figma here. It's a wonderful tool. And when designing, we love to stick into the high fidelity really fast because we are a startup. We want to work fast and scale. And we try to envision how to best showcase our findings and interact with them, make inferences, make them clickable, and understand we're telling the right story. And this example here, we're trying to figure out how to best visually represent overlays on the base map while giving the interface a life when perused. Now, there's an ongoing joke at OSK that Excel runs the world. And I think it does sometimes. Ideas and requirements, they're seldom born when you build projects, I find, in a vacuum. It's important to collaborate. At OSK, it's important to plan and ideate together as a team across disciplines, across those scientific mediums. Whether we're coordinating a product algorithm or a new UI component or image delivery to a customer, it's important to collaborate and develop a plan for that story. And this example here, we're coordinating our responsibilities for a project we're involved in called X Prize Wildfire, where we'll be using a potassium band on board our GHOST spacecraft to predict wildfires and vegetation health for our customer. Now, sometimes solving problems requires intense inspection of each other's work. And this is an example here of my coworkers going back and forth between code and design files, making sure that what we are building is up to our standard, is right, has meaning. And this is kind of just pair programming, if you want to call it that. Here we're trying to figure out what's the optimal way to center and get our cloud UI chips along and get the design ready from the design file. That's Jordan up in the top. That's Josh, and there I am. Jordan really likes Bionicle. I love seeing the Bionicle every time I talk to him. So when combined, these principles become the foundation of our system, our story, a story that is representative of the many scientists and engineers who work to make the world a better place. And here above are some examples of the product designs that we have built or ideated upon for our work. The design story also finds its way into the base maps, into the maps itself. In this example, we wanted our overlays, our findings, and our AOIs to be clear, visually representable and observable, and transparent for our user. We wanted those design experiences to be overlaid everywhere in our work to tell that story. Here's an example, another one, of where we were experimenting with hyperspectral overlaid in, say, a WebGL environment. And we wanted to see what would that look like if mapped on something. Experimentation, ideation, let's push it further. Let's bring it into a UI and ask ourselves, what story is it telling? And when it's combined, it helps us envision how the final piece could look and feel for that customer or that end user. Now, the story continues even further. I'm a designer of one, and at a startup, sometimes you get told or asked, could you make something else? And I have the pleasure of also doing a lot of our mission patches. These are some of our mission patches that you see here. I don't have 4 and 5 in here, but Ghost 1 and 2, and then Ghost 3 were also included. And that translates even further into our marketing collateral. The story echoes and is poetic in all these touch points. So lastly, before I end the presentation, I want to show you a feature that we worked on. Let me go here. I can start here. This is called cloud detections and cloud modeling. And the idea with artificial intelligence and neural networks and models is that in the 2000s, I'd say, users of geospatial software didn't have the luxury of models. They had to get the data from like a big hard drive, download it, upload it into the computer, process it, and then they'd say, oh, darn it, there's clouds. We have to go image it again. But with the power of AI and models, you can train those data sets with all of our satellite images. And I worked with a coworker, Arjun Rao, who's doing his doctorate right now at CU Boulder. And in this example, Arjun was working on a way to create a cloud model that we could feed into our Sigma platform and display it. So an end user, when they go and filter for clouds, they can say, I don't want clouds of a certain percent. I want no clouds. They have that luxury now with machine learning and models. And I'll show you that here. This is an example. You see this to the left, we have chips now that can tell you, oh, 59% cloud coverage, 78% cloud coverage. Let's check that out. Normally you wouldn't want to have cloud coverage, but you can now see it in real time from our satellite data. And if you want this one because it's 9%, let's add it. Let's add this one too, it's 1%. I'm now a GIS person perusing through our platform. Let's go to checkout. And there it is. I want these 3 images. Click next. I can assign an order name to it, a destination for the file, select which product level. As a GIS expert, I might want raw because it contains the entire file, and our NV file type. And I can place my order and boom, I have data in my hands in the server somewhere. And there's a little bit more to the platform as well I can show you. We can look at the opportunity viewer. Let's say I wanted to go to Pasadena. And I want to figure out what's the best time to take a picture here. Let me draw a square over all of San Gabriel Valley. Let me measure that too. Pretty long image, right? 45, that's a pretty long image. I can do that. I'll do a daytime collect. We don't want to do nighttime collects. I'll see the opportunistic times between this entire month, and I can view opportunities, and boom, there I have them. I can see the times when our ghost satellites will be over this area. And I can peruse through and figure out which one's the best one that I want for my imagery or for, say, a customer that we're dealing with a contract with. Now it even goes further. One last one, Ghost Tracker. This shows our spacecraft in real time. So if I zoom out here, see, there we are. There's all of our ghost satellites moving around the Earth, orbiting. You see Ghost 4, Ghost 2, Ghost 5, Ghost 3, and Ghost 1. And you can learn all about what are their specs, what's their launch date, what are they used for, Earth observation. They were launched from Vandenberg and they're active. They're up there right now. So thank you. Thank you for my presentation. And I'm glad you could listen to us today.